We're going to talk about the common ion effect and Le Chatelier's principle. Consider the following equilibrium. We have strontium fluoride in equilibrium with strontium 2 plus and 2 fluoride ions, as we have shown in this little diagram. So we're going to start off with just doing a bit of essay practice. If we add more Sr2 plus, will the amount of precipitate increase, decrease, or remain the same? Explain your answer. So I'm going to pause and you are going to answer the question. You should have responded that the amount of precipitate will increase as the additional strontium ions react with fluorine to form additional solid SrF2. So what we'll see is some of the strontium and the fluoride ions depositing and coming out of solution. This is called the common ion effect. Compounds are less soluble in aqueous solutions that contain an ion common to the equilibrium. If we add more solid SrF2 will the concentration of fluoride ion increase, decrease, or remain the same? Justify your answer. So here's another opportunity to see if you remember how to answer Le Chatelier's problems. So I'm going to go ahead and pause, and I want you to answer the question. You should have decided that the concentration of F- will be unchanged because the solid strontium fluoride is not part of the equilibrium expression. So I have written the equilibrium expression there, and you see there is no place for the solid strontium fluoride. The only thing that happens as we add more solid strontium fluoride is the pile gets bigger. The concentration of ions in solution will remain exactly the same. Okay, we have one last problem where I'm going to pause the recording and have you answer. If we add more water to the solution, will the amount of strontium fluoride increase, decrease, or remain the same? Justify your answers. So you should pause the video to answer the question. You should have answered that the amount of solid strontium fluoride will decrease as we add water. Adding water reduces the molarity of the ions, so more solid strontium fluoride must dissociate. Now, another way to answer this would be by showing what happens to QSP. So we have QSP, and what's going to happen is our strontium 2 plus has gone down, as has the F minus concentration. So that means that now QSP has to be less than KSP. So the reaction has to proceed in the forward direction to form more product. So QSP is less than KSP. So the reaction must shift forward to form more Sr2 plus and F minus. Okay, so there's your practice on calculating or on Le Chatelier's principle, applying it to KSP.